Alright guys, welcome to another exciting Unity 2D video where we are going to learn how to track our player character's movement with the camera. So I'm going to select the main camera here from our hierarchy, and we are going to add a script to this camera so that we are able to track our little red square player. So I'm going to go over a few new things in here that we previously have not gone over, some new methods specifically that are very helpful in making this happen. So we're going to create a really nice, smooth camera that follows the player around and has like a very slight little delay to it, so it tracks and has a nice organic feeling movement to it. But before we start adding that script, what I want you to do is go into the size attribute of the camera and change that to 8, just so we can see more of our little two platform level here. Okay, so to start off, let's go ahead and create a new C# script. I'm going to call this camera follow. Hit enter. Unity do its thing. And we're going to go ahead and open this up. All right, so for this script, we actually aren't going to need our start method because we don't need to do anything before the first frame updates. So I'm just going to go ahead and delete that. So let's go ahead and start things off. So the first thing I'm going to do is I'm going to create a new variable that I'm going to call target, or use a specific keyword in Unity that allows us to target another game object. So I'm going to be using the class of transform, and we are going to use the target keyword so that we can select a specific game object that we want to target its transform values to. So these are for example, its width and height, its X and Y location, etc. So this will make more sense when you see it inside the Unity editor. But for now, just understand that we are targeting another game object. And what are we targeting? We are specifically targeting its transform attributes. So I'm actually going to go ahead and start adding comments, to this just to make it perfectly clear. Allows us to target a specific game object to track its transform values. All right, so there's our first one. Next one, we're going to be using another class, vector3 class. It's just like vector2, but in vector3, you're also keeping track of the z value, which you can think of as the depth of the object on the 2D canvas. And we are going to call this offset. Set. And we are going to make a new vector3, and the values of our offset are going to be 0, -2, or I'm sorry, 0, 2, and -10. So the first is the X, the second is the Y, and the third is the Z. So this is just making sure that our camera isn't, on the same layer as some other game object. So we're making sure that there is no way that the camera can, you know, get lost in between other game objects. All right, so this is just going to offset our camera a little bit just so our character isn't just smack dab in the middle of the screen. We're just going to give it a little bit of extra space on the y-axis. And lastly, we're going to make a float. Oops. Cannot type today. That we are going to call smooth time. And we are going to set that equal to 0.25 f. Now what smooth time is going to do, this is going to be a multiplier that we are going to apply to a method that we're going to be using called smooth damp. And this is what's going to allow us to make the camera slowly follow the player so that when the player does start moving, we have this like just slight delay between the player and the camera so that the camera catches up a little bit to where the player is going. And we can change this value to manipulate how slow or snappy the camera is. Okay, and lastly, we're going to make a vector 3 called current velocity. Now, what this is a local variable, meaning that it is a variable specifically for this particular game object, which is our camera. So we are just simply storing the current velocity of the camera because we are going to reference this at a later point in our script. So for our update, we're actually going to change this to something else. We are actually going to change this to something called late update. Now what late update does is simply just waits for everything else to finish updating, and then this will be the very last thing to update. Because what we want to avoid doing if we were to use the update method for our camera, in some scenarios we might notice something happening where the camera is updating before the player moves, which we don't want that to happen. We always want this camera to update after the player has moved. So we can use the late update method to make sure that this script is the last thing that is getting updated on every frame. And this is just going to hold our one line of code that is going to keep track of the player's movement to keep track of where the player is and how the camera is going to follow and move with the player. So we are going to transform the position of the camera. So I'm going to say transform position. And we are going to set this equal to vector 3 dot smooth damp. Now this is the method that is going to allow us to slowly move the camera or add a little delay to the movement of the camera based on the player's location. So this method needs a few parameters or arguments in order to function properly. So it's going to need the current position of the camera, the location that the camera is going to go to. It needs the velocity the current velocity of the game object of this camera, and then it needs the information for the amount of time it should take that camera to move to that specific location. Okay, so let's go ahead and start giving it the parameters that it needs. So it needs the current position of the camera. So we're going to use transform dot position. This is how we can get the current position of the object that we're writing the script for. So you can see here that we're using these keywords transform.position here and updating that value to whatever value smooth damp is going to return once it's done running. So we are telling C# to transform the position of this game object based on the results of this method that we are calling here. So the first parameter is the current position of the camera, which we can just use by using transform. If I could type today. Transform dot position. The next is going to be where the camera needs to go to, which is the position of the player character. So we are going to reference our target keyword, which we created over here. This is the current, that is the game object that we are targeting. So I'm going to say target dot position because I want the position of that target. And we want to make sure that we're adding the value of our offset to that because we want to make sure we're maintaining that slight skewing of the camera so that the player isn't just like smack right dab in the middle of the screen. Target.position plus offset. Next, we are going to be referencing our local variable that I mentioned earlier, this vector3 current velocity, because smooth damp needs the current velocity of the camera in order to function properly. So in order to use this local variable, we need to use the reference keyword, which is just ref. So ref current velocity. And then lastly, it needs to know how long it needs to take to get to that target location, and we're going to use our smooth time variable in order to do that. Okay, so let's write out a comment really quick describing exactly what this is. So here we are transforming the position camera using the smooth damp method. It needs the current of the object where it needs to go. Its current velocity and how long it should take to get there to the new location. Okay, so that is really all we need to create a script that allows the camera to follow the player. So let's go ahead and save this. Open Unity back up, let it do its thing. Hopefully I don't have any errors. If we do, we'll fix that. Doesn't seem like we do, which is great. So I'm going to select our main camera game object in the hierarchy, and I'm going to click and drag our camera follow script right into it, and you can see now that we have our target. We can target another game object right here. So I'm going to select the player as our target, and now this will allow our script to use the location of the player in order to update, the camera's position. So let's go ahead and test it out. Hit play. And great, there we go. We got some nice fluid movement here. You can tell that there's a slight delay following the player after the player object does something. And we can change this. We can, make this snappier or slower by changing the smooth time variable down here. So let's say I wanted to make this like really, really snappy. I could tone this down to 0.05, and now you can see that like there is hardly any delay whatsoever, and you can't even really perceive the delay between when the player moves and the location of the camera. But this doesn't look too good, but you could take it to the other extreme. For example, if we set this to 2, and you can see now there's a huge delay. It takes the camera a really long time to get to wherever the player is. And that, for our particular platformer game, isn't really what we want. So I'm going to bring this down to like what it was before. Go like 0.25, right? Yeah, that feels good to me. So, but feel free to manipulate this, move it around, change some things about it. You can change the offset if you want, which is totally fine too. So let's say I set this to 5. You can say it's changing it on the y-axis. So let's say we want it here, and then we want to change the offset on the x a little bit. Let's say let's change it to 5 there. And just changes the location of the um, where the player is located on the screen, or based on, the viewport of the camera, I should say. That's all it takes to create a nice camera system that follows the player well. So be sure to, mess around with this, experiment with it a little bit. But that's going to be it for this video, and I will see you guys in the next one.